So what will happen? What will be the equivalent of 0 to 7 in terms of binary? Anyone tell? What will be 0?
Zero.
Okay, 0. What will be 7?
One,
0, 1,
one,
1,
one,
1.
one.
No, not 0. Okay, so I can write triple 1.
Yes.
Triple 1 will be 7. Okay. So minimum 3 number of bits are required to represent 7. Okay. So all this thing I will write in terms of 3 bits only. So 0 will be 000, 1 will be 001, 2 will be 010, 3 will be 011, 4 will be 100, 5 will be 101, 6 will be 110. Okay. Same thing I am following. I am just following its weight. This weight is 1, this position's weight is 2, this position's weight is 4. So accordingly, you can represent that number in terms of this addition of this 4 to 1. Okay. And you can put in the corresponding position once. Okay. So that means suppose 3. 3 means 2 plus 1. So you can see here 1 is there, here 1 is there. Now, if you want to represent or if you want to convert binary into octal, okay, tell me any binary number of 10, 11 bits. Any example?
110, 110.
110, 110. Suppose we want to convert this into octal. Okay. So out of this, which one is your least significant bit? This one or this one? 0 or 1?
0, 0.
0. Okay. So what to do? We need to start from this least significant bit and we need to form a group of 333 bits. So 110 will be one group. This 110 will be another group. Okay. So we started from least significant bit, then we form a group of 3 bits. Okay. Then we already wrote here from 0 to 7. Then from this we need to find out what is 110, what is its corresponding digit. So see this table and tell what is 110.
6.
6.
6. Again 110, so this will be 6. So this number in binary will be equal to 6 in octal. Okay. Same thing here. Suppose let me take another example. Suppose 1011011010. Okay. Again, what to do? We'll start from this least significant bit, means this 0. I will form a group of 3 elements. This 3, this 3. But now 1 becoming single. Here 3 bits are not there. So what can we do here? We can add 2 zeros before that. So that will form a group of 3. Now just we need to check this table and we need to write. What will be 001? What is 001?
1.
1,
1. 011?
3.
3. Again 011? 3. 0102.
2.
So this number in binary is same as 1332 in octal. Okay. Now another example here, as you can see. Okay. So here decimal point is there. So after this point, we know that this will be formed group of 3 elements, 3 bits. Then to the right of this also you need to form a group of 3. So now what will happen here? First one is here 001. What is 001? Its equivalent is 1. Next group is 010. Its equivalent will be 2. Then triple one is how much? 7.
7.
Then dot 100 is 4. So this will be 127.4 in octal. Okay. So in this way you can convert binary into octal. Okay. Next. Or it is vice versa is also true. Suppose a octal number is given, then also you can write, suppose it is mentioned that 236 octet is given. We need to find its binary. So what will be its binary? For 236, what will be its binary equivalent? Just now we need to check this table and we need to write 2 is how much?
Yes, sir.
010. 3 is 011. 6 is 110. Okay. So in this way, either we can convert into binary into octal and vice versa. We can convert back octal into binary. Next, hexadecimal. So in hexadecimal, what we are doing? We are using 0 to 9, then we are using A to F. Okay. So what we will do here, again we will do the same trick here. So to convert binary into hexadecimal or to convert hexadecimal into binary, we will require first that table. So I'm writing that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then is A, B, C, D, E, F. So what will be 0? 0 will be 40, 1, 0001, 2, 0010, 3, 0011, 4, 0100, 5, 0101, 6, 0110, 7, 0111, 8, 1000, 9, 1001. Again, I am following the same trick only. I am not doing something intelligent thing. Again, this is only 1, this is only 2, this is 8, 4, this is 8. So, depending upon this only, I am writing all this. So, similarly, what will be for A? A is how much? 10. So, what I should write for 10? 10 will be what? In terms of 8, 4, 2, 1? It will be 8 plus 2. So, what will happen? What will be A? क्या होना चाहिए A?
1010.
1010. Similarly, B, which is 11. 11 is 8 plus 2
1011.
plus 1. So 1011. Next, C is 12. So 8 plus 4. So 1100. 13, 8 plus 4 plus 1. So this is 1101. 14, 8 plus 4 plus 2. So 1110. 15, all are 1. Okay. Now exactly again same trick here. Now because it is a hexadecimal, we need to make a group of 4 bits. This example is given here. So again we'll start from least significant bit. We'll form a group of 4. So if we'll check first is 1011. What is 1011? You can check here. This is B. Then 0110. You can check here. This is 6. Then 0101. This is 5. 41. This is F. So this binary number is equal to B65F in hexadecimal. Same thing, another example is mentioned here. Okay. So first of all, again, same to do. What to do? We'll make a group of 4. So we'll start from here, make a group of 4, make a group of 4. Now only 2 are remaining. So we'll add 2 zeros here. Similarly to right hand side of this, 0.111. So again 3 bits are there. So we'll add another 0. Okay. So now if we'll see from the most significant bit 0011. So 0011 means what? What is 0011? You can check here. It's pink color. So this is 3. Then 0110. 0110 is 6. Then 0101. This is 5. Then 1110 is E. So this binary number is equal to 365 point E. So in this way we can convert binary into hexadecimal. So vice versa is also correct. Okay. Suppose it is given as 129 B point C. Okay, it is given in hexadecimal. So what will be its binary number? What will be its binary equivalent?
0001.
1. First one means 0001. Then 2, what is 2? 2 is 0010. 9. 9 is 1001. B is 11. 11 is 1011. Point C. C is 12. So 1112. double zero. Okay. So in this way, we can convert binary into octal and binary into hexadecimal and vice versa. So same thing from 0 to 16, it is binary given, octal given, hexadecimal given. Okay. Next. Okay. So next we'll learn about how to do the binary addition and subtraction. Binary addition and subtraction. So if we'll add two 1-bit numbers, four possibilities are there. In binary we are only dealing with 0 and 1. Okay. So four possibilities are there. It can be 0 plus 0 or 0 plus 1 or 1 plus 0 or 1 plus 1. Only four possibilities. Okay. So if I'll add 0 with 0, what will happen? What will be the output?
0.
Zero.
Okay. Anyone else? So think little bit and tell. First of all, how many output we should get when we used to add? How many output we used to get? Normal in decimal also. If you add two digits in decimal, how many outputs you'll get?
1.
No. Think little bit. Suppose you add two 1-bit numbers, 9 and 6. What will be the result?
15.
15. But you add two one bit, you add one digits, na, but you are getting here two digits. So what is this and what is this? It is called as sum. This is called as carry. This is called as carry. So basically we are getting two output. One is sum, one is carry. Okay. Because you can see this now, 19 plus suppose 23. So what happens? 9 plus 3. So this will become 12, means this will be 2, carry will go to the next one. Okay. So this will become 2 plus 1 plus 1. This is 42. Okay. So when you are adding two digits, you are getting one sum and you are getting one carry. So here it is 0, that doesn't matter. When you are adding 1 plus 1 plus 2. Okay. So basically what will happen, when you will add, you will get two outputs. I'm adding two 1-bit numbers, I will get two output, which will be called as sum and carry. So accordingly we will write sum and carry. So 0 plus 0. As you told, sum will be 0, carry will be 0. 0 plus 1, what we should get? 0 plus 1,
Someone carry zero.
sum 1 carry 0. 1 plus 0, again sum 1 carry 0. 1 plus 1,
One. Someone carry.
sum 1 carry
One.
uh,
Some zero carry one.
okay. So why sum 0 carry 1? What is the reason behind it?
So 1 plus 1 will be 2 and its binary is 1 0.
Yes, correct. But you are saying 1 plus 1 will be equal to 2. But we are adding here binary numbers, na? They are not in decimal.
So 1's decimal is 1.
Yes. So when you are adding 1 with 1, this 1 in binary is same as 1 in decimal. Okay. So when we will add them, this 1 plus 1 will become 2. 2 in decimal. So this result has to be binary equivalent of this. So what is the binary equivalent of 2? Binary equivalent of 2?
1 0.
1 0.
1 0.
1 0. Okay. That means what? This one is sum, this one is carry. So sum is 0, carry is 1. Okay. So we can try this. 0 plus 1, sum is 1, carry is 0. Then 1 plus 1 plus 0, what will happen? Sum 0, carry 1. Then 0 plus 0 plus 1, sum is 1, carry is 0. Then 0 plus 1 plus 0, sum is 1. So output will be 1 1 0 1. Let us verify this, whatever you got, is it correct or not? We don't know. So 1010, what is its decimal equivalent? Decimal equivalent of this is 10. Okay. 0011?
2.
No, not
Sorry.
2.
3. 3.
3. So 10 plus 3 should be 13. Verify this. How much is this? This is 13. 8421. So 8 plus 4
Yes.
plus 1 is 13. Okay. So this is about the addition. Next, subtraction. Okay, like we got two outputs in case of addition. Similarly, what will happen in subtraction? How many output we should get in
1.
subtraction? No, again, same thing. It is similar to. It is similar to. 1 second. It is similar to addition only. 1 second. Huh? Hello. हाँ सर गुड मॉर्निंग हाँ सर क्लास ଚାଲିଛି ସ୍ନୋ ରିଭର୍ସ ମୁଁ ସଡ଼ନ କଲ୍ କରୁଛି ଆଉ ହଁ ମୁଁ 10ଟା ସାରିଲେ ଯିବି ଆଉ ଆପଣଙ୍କ କେତେବେଳେ କ୍ଲାସ୍ ଅଛି ହଁ 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 okay so here when we'll go for subtraction like addition you get two outputs okay one is difference one is borrow same thing it happens in decimal also okay now when you used to do 17 suppose 27 minus 19. Okay, 7 minus 9 will not be possible. We will require a borrow from the next digit. So here also happens exactly the same thing. So here also we'll get two output, difference and borrow. So 0 minus 0. First of all, do you require any borrow for this? 0 minus 0?
No, sir.
Not required. So borrow will 0, 0 minus 0, difference will be also 0. Now 1 minus 0, again this is larger, this is smaller, borrow is not required, so borrow is 0. 1 minus 0 will be how much? This will be equal to 1. Then 1 minus 1, what will be 1 minus 1? Do you require any borrow here? 1 minus 1?
No, sir.
Both are same, borrow not required, borrow is 0. Difference is also 0. 1 minus both are same, so 1 minus 1 is 0. 0 minus 1. So here you require a borrow. Here you require a borrow. So borrow will be 1. Okay. Then what should be the difference? What should be the difference here? Difference क्या होना चाहिए? Just to correlate, you can take this example 27 minus 19. What you used to do? You will take a borrow from here to here. If borrow will come, if one borrow will come from this to this place, what will happen? This will become 17. And how much will remaining here? 1 will be remaining. Next, what used to do? 17 minus 9, which will be equal to 8. Then 1 minus 1, this will be 0. Okay. So exactly same thing is happening here. When borrow comes here, what will happen? This will become 1 0. So now what happens? This becomes 1 0 minus 1. 1 0 minus 1. So next we should know what is 1 0 minus 1. Okay. What is the decimal equivalent of 1 0?
2.
2. Decimal equivalent of 1?
1.
1. 2 minus 1 should be 1 only. So this is 1 in decimal. So it should be same as binary also. This should be also same as the binary. So 0 minus 1 is same as this result is difference is 1, borrow is 1. Both are 1 1. Okay. Now let us try to solve this example. 0 minus 1. Now 0 is smaller, 1 is larger. So you will take a borrow from this place to this place. So this will become 1 0. How much will remain here? This will
0.
become 0. That means when you take a borrow from this to this place, this becomes 1 0. So 1 0 minus 1 is this difference is equal to 1. Next, 0 minus 0, this will be 0. 1 minus 1, this will be 0. 1 minus 0, this will be 1. Okay. Let us verify whatever we got the correct results or not. What is 1110? Its decimal equivalent. This is 14. 0101, this is 5. 14 minus 5 is 9. What is 9's equivalent? It is 1001. Okay. Next, try to solve this example. Make this as a subtraction and try to solve.
ଅଟୋ ଗୋଟେ କରିଦେଇଛି 15 ଟଙ୍କା ये ये इस तरीके की जांच
Anyone got the result? So this is 1010. This should be 10. 0011. This is
So triple
3.
one.
It should be triple one, 0 1 1. Okay. So all of you getting 0 1 1 1. What will happen? First of all, 0 minus 1. 0 minus 1. Okay. If it is 0 minus 1, what will happen? Borrow will be taken from here. This will become 1 0. Once this 1 goes to there, here 0 is remaining. Okay. So 1 0 minus 1, difference already because borrow is taken, difference is equal to 1. Now there is a issue. What is the issue? Here it becomes 0 minus 1. Here it becomes 0 minus 1. Okay. We need to take borrow from the next bit, but here it is already 0. We cannot take borrow from this. Okay. So what will happen? From here we need to take borrow. Yes or no? If we'll take borrow from this place to this place, first of all, how much will remain here in this most significant bit?
0.
0 हो जाएगा. Great. And 1 0 will come to this.
Yes.
Now, from here, we need to take a borrow to this. Okay. So if we'll take a borrow to next bit, what will happen? First of all, this will become 1 0. So the now question is, how much will remain here?
1.
1. Okay, great. Why 1?
So because 1 zero's equivalent is 2 in decimal.
Yes. Okay. Don't take that mistake. Students what generally used to do, what they will do, they will take this one, so they will write it as 0. It is not like that. Out of 1 0, 1 will go. That means how much will remaining? This 1 will be remaining. So this will be 1 only. So now 1 0 minus 1 is 1. 1 minus 0 is 1. 0 minus 0 is 0. Okay. So that is all about the addition and subtraction. So from here, what we understood, this addition is different and subtraction is different, or both are same. This process, both are different or both are same. ये दोनों same है. It looks same. Both are having two input. Both are having two output. But outputs, is it same? Results, is it same? Results are different. So now if we'll think about the implementation, suppose I will require a circuit. I will design a circuit which will do the work of this addition. Then I will require a circuit 1. If I will require a circuit for subtraction, I will require another circuit 2. Now what is happening? We are requiring two different circuit to perform this task. But this process are quite similar. This process is quite similar. How? For that, one second, let me show you. 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1.
So,
Sum, carry. Yes.
so there is one doubt in addition.
Yes, tell.
So if in place of 1010, if we had 1011, then what will the result?
In this example,
Yes, sir.
tell me two numbers.
1011 and 0011.
0011. Okay. So what will happen here? 1 plus 1, 0, sum 1.
Yes,
Now you will add 1 plus 1 plus 1. This equivalent to what? 3 in decimal. So what will be its equivalent? Sum 1, carry 1. You are adding 1 with 1 with 1. These are in
yes.
binary. So
Okay,
it is
sir.
same as its decimal only. 1 in decimal, 1 in decimal, 1 in decimal. So it should be 3. 3 means what? 1, 1. That means sum is 1, carry is 1.
Okay, sir.
Then this will be 1, this will be 1. Okay.
Yes, sir.
Now, 1 plus 0, sum is 1, carry is 0. 1 plus 1, sum is 0, carry is 1. Okay. Is it correct? Now you check this two. Is it same or any difference is there?
Same.
Difference is exactly same as the sum. What is the difference? Difference occurs only in the carry and borrow. That too only in some place. Where? Here and here. Okay. So they are quite similar in working. Okay. So what we can do instead of going for, because basically we'll go for addition and subtractions. So what we can do, instead of going for two different circuit, I can design one circuit which can perform the both the work. Okay. So basically what we'll do, we will try to convert subtraction into a addition problem, so that with the help of one circuit only, we'll be able to perform the both the task. We can get a addition and subtraction. So how we're gonna convert that addition into subtraction? That we'll see. So if I'll tell you, suppose uh, I want 7 minus 3. Can I write like this? 7 minus 3 as 7 plus minus 3. Will it be fine?
Yes, sir.
So basically what happens here? Now the subtraction problem is converted into a addition problem. So if you know how to represent minus 3 and how to represent plus 7, then we can add this 2. By adding this 2, we can get the result. Okay. So two things is important now. How to represent this minus 3 or this negative numbers. Once I know how to represent negative numbers, then I can convert this subtraction problem into a addition problem. So that thing we'll learn in the next slides. Okay. Okay. Now let us understand some other basic steps. So this is again same thing we already discussed. This representation of unsigned numbers. That means whenever now we convert this decimal number into binary number. Have we discussed about any signs, positive sign or negative sign when we
No,
convert?
sir.
We
No,
have not
sir.
discussed here. So no sign means it is called as a unsigned number. Okay. Now think about it. Now suppose you have a single bit. Okay, you have only one bit. So one bit can be 0, one bit can be 1. Okay, one bit. Okay. So what is the decimal equivalent of 0? 0 only. Decimal equivalent of 1? 1 only. So using this one bit, we can represent minimum to be 0, maximum to be 1. Now, now suppose I have two bits with me. Two bits. Okay. So what can be the possibility? It can be 0, 0, it can be 0, 1, it can be 1, 0, it can be 1, 1. Four possibilities are there. Yes or no?
Yes, sir.
Out of this, which will be minimum and which will be the smaller number, which will be the largest number?
Zero zero is minimum and
0,
one
0
one
is
is
minimum, 1, 1 is the maximum. What is decimal equivalent of 0, 0? 0, 1, 1, 3. So when you go for two bits, minimum we can present 0, maximum we can present 3. Okay. Similarly, if I'll go for 3 bit, how many combinations are possible? 8 possible combinations are there. Okay. So I'm not writing about all. So basically, let me write also otherwise. So these are the 8 possibilities. Okay. So who will be minimum? This will be minimum. Triple one will be maximum. So minimum is what? 0. Maximum is what? 7. Okay. Next, if we'll go for 4 number of bits, if we'll go for 4 number of bits, what will happen? What will be the minimum one?
zero.
Minimum
Zero.
will be 0. Maximum will be 4
15.
ones.
F
4 1 means 15. Similarly, if I'll go for 5 bit, minimum will be 0, maximum will be 5 ones. 5 ones means 31. Similarly, if I'll go for 6 bit, minimum will be 0, maximum will be 63. So now, if I generalize this, if I'll write n number of bits, okay, then what will happen if it is an unsigned number? We can represent what? So obviously, minimum is 0. So 0 to, what will happen to the maximum one?
2 power n minus 1.
2 to the power n minus 1. Okay, so remember this. When you have n number of bits, so 2 to the power n number possible combinations are there. Possible combination can be always 2 to the power n. If you have two number bits, four possible combinations are there. Three possible to 3 bit, eight possible combinations are there. Okay. 4 bit, 16 combinations are there. 5 bit, 32 combinations are there. And using this n number of bits, if it is an unsigned number, you can represent from 0 to 2 to the power n minus 1. Okay. Next, to understand that we discussed in the previous to previous slide about the converting a problem of subtraction into a addition. Okay, we need to understand about something else which is called as ones complement and twos complement. Once we understood this, then we can represent the signed numbers, that means positive numbers and negative numbers. Once we understood about the representation of the signed numbers, then we can convert the problem of subtraction into a addition. So for that purpose, let us first study about this ones complement and twos complement. Okay. So this complements actually basically this can be called as actually r's complement and r minus 1's complement. Okay, so this r is nothing but the base of the number system. Base of the number system. So for decimal, its corresponding will be tens complement, nines complement. Okay, as it is binary, base is 2. That's why it is 1's complement and 2's complement. Okay, now tell me any 4-bit binary number. Any example of 4-bit binary?
1101.
1101. So first thing is we will find out what is the ones complement of this 1101. So any binary numbers ones complement we can find out by subtracting all the ones from this. So if we'll subtract 1101 from 4 ones, okay, here it is 4 bit, that's why I'm taking here 4 ones. Okay, so if we subtract 4 ones from this, then you will get the ones complement. So what will happen? This 1 minus 1, 0, 1 minus 0, 1, 1 minus 1, 0, 1 minus 1, 0. So one's complement of 1101 is 0010. Okay. Now tell me another example of 5-bit number. Any 5-bit number?
11011.
11011. Okay. So one's complement of 11011. Okay. So what to do? Now it is 5 bits. So we need to subtract 5 ones. We need to subtract this number from 5 ones. So what will happen? 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. So this number's one's complement is this. This number's
But
one's
this is just
complement is this.
algebraic subtraction, right?
Yes, it is only the subtraction. Okay. So, but what happens if we look closely? Now observe this and this. Okay. Can you find any similarity here or any correlation?
Yes, sir.
What?
It's only that number is one is switching to zero and zero is switching to one.
Yes. Only thing is now just numbers are getting interchanged. Okay, 1 is changed to 0, 0 is changed to 1. Okay, so this 1 is changed to 0, this 1 is changed to 0, this 0 is changed to 1, this 1 is changed to 0. Exactly same thing is happening here if you observe. 1 is changed to 0, this 1 is changed to 0, this 0 is changed to 1, this 1 is changed to 0, this 1 is changed to 0. Okay, so whatever binary numbers are given, if you want to find the ones complement, then what to do? Just interchange zeros with 1 and ones with 0. Okay, so in digital actually this is very important and very easier also to interchange. So if you have studied, otherwise you study later on, if you remember about NOT gates, have you studied about these NOT gates?
Yes, sir.
Okay, so what
Yes,
happens here? If input is A, output will be A bar. That means what? If input is 0, output will be 1. If input is 1, output will be 0. So it is basically nothing but this complementing option. Okay, so just the NOT gate option. By using this NOT gates, we can get this ones complement. Okay, so is this clear how to find ones complement of any
Yes, sir.
binary number?
Yes.
Just another example here now. First of all, here question is represent 57 using 8 number of bits. Let me ask another question. So using how many minimum number of bits I can represent 57? Using how many minimum number of bits I can represent 57? So maximum will be 6. We discussed here we can represent 0 to 2 to the power n minus 1. Okay, so by using 5 number of bit, we can represent from 0 to 31. Using 6 number of bit, we can represent from 0 to 63. So 57 means it will be 6 bits will be required. So let me take first 6 bits. So this is 1, this is 2, this is 4, this is 8, this is 16, this is 32. What is 57? 57 is equal to 32 plus 16 कितना हो गया 48 48 plus what I should write 8 56 plus 1 57. So in those corresponding positions I need to put 1, other positions I need to put 0. Here using 6 number of bit, but question is exclusively asked to use 8 number of bits. So what will happen? It is already 6 bit, so I will add another 2 bits to the left hand side of this. I can add 0. It makes sense. Okay. So 57 is equal to 00111001. Okay. Now, if I want to find it ones complement, what will happen? What will be ones complement of this? Just we need to
Interchange 0 with
interchange.
1.
So 1, 1, 0, 0, 0, 1, 1, 0. Okay. So same thing is mentioned here. So ones complement clear? How to find the ones complement? Is it clear?
Yes.
Yes, sir.
Okay. Next. Next is two's complement. Two's complement, how can we find out? To find two's complement, first we need to find the ones complement. Then if you add 1 to it, then it will give you the two's complement. So here already ones complement you calculated. Here if you add 1 to this will give you the two's complement. So what will be the result? 1 plus 0, 1. 1 means what? All others are 0 only. So same thing will come. Okay. So 2's complement of 57 will be double 1, triple 0, triple 1. Okay. Now we understood about 1's complement and 2's complement. 1's complement, no need to subtract. Just by interchanging, you can find the 1's complement. But 2's complement, what we need to do? First of all, you need to find 1's complement. Then you will add 1 to it. Okay. So this is becoming little bit lengthy. Okay. So what we'll do? Somehow we'll try to learn directly by looking into the binary number. We'll be able to write the 2's complement. So to understand that, we'll go for two examples of 104 and 105. Okay. Or let us take a smaller one. Okay, 1 second. Suppose one is 14, one is 30. Okay. Suppose you use the minimum number of bits. So how many bits will be required? Four number of bits will be required. Okay. Now 13. What is 13? 13's binary
110.
1101. 30 bits one's complement
0010.
0010. Just interchange. To find two's complement, we need add 1 to this. So what will happen? 0 plus 1, 1. 1, 0, 0. Okay. So two's complement of 13 is 0011. So number is 1101. Its two's complement is 0011. Okay. Now let us check for 14. What will be 14? 14 is 1110. What will be one's complement of 14? One's complement कितना होगा?
0001.
1. Okay. To find two's complement, we need to add 1 to this. So 1 plus 1, sum is 0. Let me take another color. Carry will be 1. 1 plus 0, 1. Then 0, 0. So what happens? Triple one zeros, two's complement is 0010. Okay. So the shortcut is, first of all, you need to start from least significant bit. First of all, what is the binary number? Suppose this is the binary number. Then we'll start with this least significant bit. Whatever will be the least significant bit, you will copy this. Okay. If it is 1, then what happens? After that, you interchange zeros with 1 and ones with 0. Okay. So it is already 1 here. So what happens? 0 is interchanged to 1, 1 is interchanged to 0, 1 is interchanged to 0. Check the second case. Here it is 0, 0. So 1 didn't came. So what happened? If we are not getting 1, till the time we are not getting 1, we need to copy. So here I am getting the first one. Once you get the first one, then what to do? Then interchange. So we'll interchange 1 with 0, 1 with 0. So how to write the two's complement of any binary number? You'll start from the most significant. You'll start from the least significant bit. You'll keep on copying till you get the first one. Once you get the first one, then you will interchange. You'll
Sir, we
interchange
should get one in both ones and twos or any
one
one.
once in both mean.
Means we need to get one in both ones and twos complement
No.
and check.
Only this binary number. I didn't write one's complement. No, I'm checking from here only, from this binary number only.
So,
So
sir,
we'll
what
not
you are telling is how to get two's complement directly.
directly. Take another example. Okay, give me another example. Any binary number.
110011.
110011. So what I will do? I will copy from this least significant bit. So I copied one. Because I got the first one, then it will get interchanged. This one will become 0, this 0 will become 1, this 0 will become 1, this one will become 0, this one will become 0. Okay. Now suppose, take another example, 110000. Okay. So what to do? We'll keep on copying till we get the
Until we
first
get
one.
1.
So 0, again 0, again 0, again 0, 1.
1, 0.
First one is encountered,
0.
after that interchange. Okay. So you can see here also in this example 104. This is 104. Okay. So we'll copy this. 0 comes here, 0 comes here, 0 comes here, 1 comes here. Here we got the first one. Once you get the 1, then you can see it is interchanged. All these are interchanged. Whereas here 105, in first place only 1 is there, so all others are interchanged. Okay, is it clear?
Yes, sir.
Okay, so another example. So we have done it for 13. Okay, so now suppose question is you represent this 13 using, or you find 2's complement of 13 using 8 number of bits. Okay, then what will happen? What do you think? What will happen? 13th already we have done here. We got the result here. Okay. So what should happen to the 2's complement of 13 using 8 number of bit? Obviously 4 bits are there. Another 4 bits needs to be added. Yes or no?
Yes,
Then
sir.
what
Yes.
to do?
Add 4 zeros in front of it.
4 zeros of this. Okay, let us see. We need to add 4 zeros or what? Let us first solve manually, then we will see what will happen. So what will be 13 using 8 number of bits? 13 is 1101. 4 zeros needs to be added. Okay. So what will happen? To find its 2's complement, I will copy this one. 1 is encountered. After that, everything needs to be interchange.
One
So what
double
will
zero,
happen?
4 times 1.
Okay. Now you just compare this with this. What is getting added?
4 times 1.
Ones are getting added. Okay. So when you are dealing with one's complement and two's complement, don't just put those zeros there. Okay. Don't put the zeros there. Always follow the simple steps. Okay. First 8 bit is given means you first represent 13 using 8 number of bit, then find the 2's complement. Okay. So don't put, you have done this here, don't put simply 4 zeros before that. You can put 4 zeros only for the simple binary number. You cannot put that for others, one's complement and two's complement. In one's complement also it will not be valid. बिकॉज तुम जीरो अगर पुट करोगे वंस कॉम्प्लीमेंट में क्या हो जाएगा वो तो कॉम्प्लीमेंट हो जाएगा ना दैट विल बिकम वन सो डोंट डू दैट मिस्टेक ओके ओके लेट अस स्टॉप हियर other thing we'll see in the next class we'll see about how to represent the sign numbers okay 1 second don't leave the meeting
Okay, sir.
let me take the attendance